No. Chinese Statistical Association for hosting this exciting event. I want to thank the panelists for sharing their insights with us on this Sunday morning. It was so energizing to see so many of them agree to participate with such a short notice. It is definitely a very important topic that concerns many of us in the community. I want to remind everyone that this session is being recorded and live streamed on YouTube. We're also hoping to summarize the insights into a publication for a statistical audience. This chat is hoping to channel the excitement or concerns we feel about statistics in the era of AI towards actions we could take as a community to empower statistics and statisticians. Our conversation today and forward actions build upon so many prior discussions, including a 2019 NSF-sponsored report, Statistics at Crossroads, Who is Up for Challenge, led by James Berger, David Madigan, Xu Minghe, Susan Murphy, and John Wellner. I will post a link in the chat after this opening. Many of the participants of that effort are here today on the panel. We hope to continue all this effort in concrete ways and to drive progress. Without further ado, I'm passing this webinar to our leading host, Xihong.
And thanks a lot, Tian. I would like, as this is Xihong Lin from Harvard University, and I would like to add my thanks to all the moderators, panelists, and discussant attendees for joining us on this Sunday morning for an enlightening fireside conversation on statistics and AI. Statistics, as we know, as a science of learning from data by accounting for uncertainty, play a pivotal role in understanding science and society and also assisting with decision-making process. So the rapid advance of AI has revolutionized how to utilize the data and how to enable machine to learn from the data. Many stimulating discussions, including both concerns, worries, and excitement, have emerged, such as the recent discussion in the North American Chinese Statistics and the Biostatistics Faculty WeChat group. So this discussion centered around the challenges, opportunities in both theoretical and applied statistical research, as well as reshaping the landscape of statistical journals and statistical education in the age of AI, and how statistician can have a visible seat at AI table. So this led to this fireside chat event. So this fireside conversation event marked a small step towards fostering proactive and thought-provoking discussion of the issue we face and how the community can work together collectively and brainstorming potential action. So it would be very valuable if we all can be open-minded, think out of the box, and be willing to take risk and be forward-looking during the discussion today. So overarching goals are twofold. One is to empower statistics by leveraging the transformative potential of AI. Another is to enhancing trustworthy AI by incorporating rigorous statistical principle and thinking. So the ultimate goal is to make an impact in the real-world science and accelerate scientific discovery by leveraging the power of integrated statistics and AI. So this event has 3 sessions, and rethinking statistical research, journal, and education in the age of AI. And for each session, each panelist will have 4 minutes, and to ensure we have time for discussion while maintaining a light-hearted atmosphere with some fun and laugh. The music will be played at the end of each 4-minute segment. And following the presentation in each session, and we are honored to have our discussant, Professor Dave Donoho from Stanford University, to provide his response and share his insight. Then we will open the floor for Q&A. All attendees are encouraged to submit your question in Q&A in the WeChat during the presentation and the discussion. So let's start from session 1. And I will serve as the moderator. So this session focuses on challenges and opportunity in statistical theory and method and application research in the age of AI. We have 6 panelists. So we would like to start with the first panelist, Hongtu, Zhou, and from UNC Chapel Hill.
Okay. And this is Hongtu from the USC Chapel Hill. It's my great pleasure to be the first speaker. And go to the next slide. And actually, I think there are three major challenges we are facing from the statistical community. And to me, these are the outcomes, okay? And basically, the first one is more and more talented students choose machine learning and the ECE departments instead of statistical science. The second thing is we have seen many funding opportunities for the AI-related research from both the federal government, all kinds of federal agencies, and also private sectors. And the most worrisome is basically you have seen many new domains with a few statisticians involved. Okay, that's the three major challenges. Could you go to the next slide? And I wanted to re-emphasize the current, the ecological layout for AI. This wave of AI started with two novel ideas, both from the universities. One is the ImageNet, and another one is the convolutional neural network. Okay, it's deep learning in general. And actually, the private sectors, recognize the potential of these two innovations, and actually they invested heavily to develop products that garnered significant attentions across social medias. Could you go back? And the government and the public and then public. And at the same time, the federal agencies and also federal government recognize this importance of the AI related research and invest a ton of resources. Okay, could you go to the next slide? And I think that's basically the situation we are facing these days. And actually, another thing we discussed is about the statistical theory. My personal opinion, I use the Google chat. You use ChatGPT to write this. Is a collection of mathematical tools or formulation that can substantiate statistical method on some reasonable assumptions. And actually, as a statistician by training, I regard statistical theory as a critical component of statistical method. I think it's super important. One successful story I'm talking about basically like empirical process or related method. And I think that the statistical theory is super important if it can tell us when and why some powerful statistical methods work in important applications. This is how do I regard the statistical theory. And actually, there's some issues happening in the last 10 years. It seems like the statistical theory fall behind in the AI areas, mainly due to two complexities. One is data complexity, another one is method complexity. If we could read Leo Braidman's 2001 papers, they're talking about stochastic data models and algorithmic models. I think that the problem is one thing is in the traditional statistical models and not reasonably accurate for many complex applications. Well, that's the one issue we're facing these days. Another thing is for many novel methods like random forest, deep learning, and deep reinforcement learning, they are very important. We have little theoretical results about all these important and emerging challenges. Actually, recently I read Dr. Donoho's and the recent paper, Data Science in Singularity. He basically summarized the new method evaluation systems, basically using data sharing, code sharing, and competitive challenges. It seems like we don't need a theoretical result, theoretical statistical theory in certain degree, but actually it's not. I'm just to raise these kinds of questions for people to discuss. Thank you.
Okay, so yeah, I'm Jiashun Jin from Statistics Department at Carnegie Mellon University. I would like to thank Xihong and several others for organizing this wonderful event. It's my great pleasure to have this opportunity to share some of the thoughts on AI. Next slide, please. Clearly, AI is a success in many areas, but it also has many issues from my own experience and from what I heard on the WeChat group. One issue is that the current approach of AI research is very expensive. It's not clear whether such an approach is sustainable in the future. but it's clear that it's quite hard for us to conduct research in the same way. Another issue is that AI creates a false public impression that other research areas are useless. But what really happened is AI feeds on many other research areas, reinvent many of the existing ideas. There's a serious worry that in the near future, original ideas in many areas may be forgotten, replaced by a reinvented version of the idea. Still, another issue is the answers by the AI are frequently incorrect. Next slide, please. Allow me to support my last point by one of my recent experience. Motivated by the success of the Google team of AI for Science, I have been collaborating with a young researcher at Google on a project recently where we wish to use AI to solve the well-known NIP problem in some special cases. We consider setting that are comparable easy for a math PhD student. And at the same time, we feed in the AI with some papers, theorems, and a specific problem-solving strategy. We find that the AI is able to produce a nice summary on the papers and theorems, but it really does not understand the math, underlying math. Okay, next slide, please. As for theoretical statisticians, I do think that they are appreciated in many scientific areas and industries, with steadily growing hires in recent years. Take the financial industry, for example, which I'm more familiar. Their modeling skills, and especially the so-called white box algorithms that theoretical statisticians developed in the past and currently are widely appreciated. And the production manager in the finance industry are more confident with models and signals with intuitive explanation. This also shows that theoretical statistics are quite useful. However, from what I heard from the WeChat group, the area of theoretical statistics also has many issues. One issue is that the journal review process and the knowledge iteration is relatively slow. Another issue is that the area has invested heavily on familiar and unrealistic settings with limited interest in data, experiment design, and so on and so forth. Still, another issue is that promotion and evaluation heavily relies on journal publication. This, in effect, penalizes on non-conventional research, which may produce fewer publications. Next slide, please. Next slide, please. Yeah, here. Thank you. Okay. For example, for theoretical statisticians, collecting new data set is important but non-conventional task. It frequently takes many years to collect, clean, and analyze a large-scale, high-quality data set. However, from my own experience and from what I've heard from the WeChat group, it's hard to turn this huge effort of collecting data into top journal papers. Next slide, please. So based on what I heard on the WeChat group, I have the following suggestions. First, we need to create an environment that encourages non-conventional research. Second, we need to reform the curriculum and the publication venue. According to what I heard, some of these efforts are already underway. Last, we may want to consider the Hilbert model, the Hilbert 3 problems, which is well known, where we identify a list of challenging and important problems. The Hilbert model may help us in many ways, especially it can help us aggregate our limited resources to solve a few important problems. And only by this way, it's possible for us to compete with the tech giants such as OpenAI, Google, and so on and so forth. Okay, this is all I have to say. Thanks for your attention.
Thank you, Jiashun. We'll move on to the next panelist, Tianxi Cai from Harvard.
So next slide, please. So as Jiashun and Hongtu both have mentioned, there are definitely a lot of excitement and also limitations in the at least current AI models available to us. But at the same time, just putting that aside, I would say in the past 5 to 10 years, we as a discipline have been encountering a huge amount of increase in data, both in terms of data modality, the size, and diversity. So many researchers on this panel have done a lot of research, for example, in imaging, genomics, text, and also many data sets that actually have many different modalities. these are all very exciting opportunities because it sort of forces us to think about what are the novel methods that we can develop. But I think if we compare, or I take a step back, I have a joint appointment in the Department of Biomedical Informatics. So I often sit in the meeting with my colleagues who are trained in machine learning or computer science. And I often sit there, I do feel the pressure and feel that we need to sort of rethink, like we as a discipline, what is our major contribution or our special strength in this field? I would say given the past couple years, there has been a lot of progress within the statistical community that we are much more capable of accessing, analyzing, and interpreting a variety of data types, including like image, text, or voice. But at the same time, because of our discipline caring about whether the phenomenon or the result we see is a reflecting randomness or it's some fluke in the data, we care about robustness, and of course we face additional challenge of sharing privacy. So there are many interesting work in federated learning. And from the machine learning world, we now see a lot of need for us to incorporate highly nonlinear effects. And we have many methods developed at the same time. But just like Jiashun mentioned, there has been a lot of principles that we have seen in the machine learning field in a way, like we as a discipline look at it, say, isn't that similar to what blah? So I also think there's a gap between like what we produce to what actually ultimately get to be used in actual world, solving real world problems. In that regard, I totally agree with Jiashun that we really need to think about how we can actually become more and more of sort of have more and more ability to do end-to-end. We need to have the ability to collect data so that we are not waiting for someone to process the data, hand us a very nice clean data matrix. And we also tend to ignore the last mile. We actually have very nice methods, but it kind of ends there. Like we have prototype, we have really nice methods published in our top journals, but outside the discipline actually don't see what we produce. So I think we need to think a little bit more carefully about how can we actually sit on the table from the very beginning to the very end, have a product that we produce. So I think there will be many more discussions in that regard. And that's it.
Thanks, Tianxi. And we will move on to the next panelist, Haoda from Eli Lilly.
Okay, that's great. So I'm going to share the story and also talk about the potential actions. This potential action is coming from our groups. So the short stories is from the XGBoost. Probably people know these days XGBoost is a kind of widely, broadly used winning solutions for the structured data analysis. They even outperform for the deep learnings in the structured data side. But here is the story, and this story talks about the statisticians, computer scientists, and how they work together, and how we should push to the last miles, as Tianxi just mentioned. Actually, the story coming from kind of 30 years ago, starting from one of the questions, can we do the majority votings and get the best result? But after the idea posted out, people try and learn for the next 8 years, they don't have a good result until the XGBoost method was proposed by a computer scientist. At the moment, people probably still remember in the 1997, they called the best out-of-shelf classifiers. But sometimes it works, sometimes it doesn't work. So I will call this like more like the technologies, lot of similar like today's deep learning technology. But only after our statisticians, one of the annals discussion paper come out, and they moved this can better understand ADA boost, understand the ADA boost is the equivalent to the exponential loss functions that not robust to the outliers. Then we get this additional theoretical insight helping us to get the gradient boostings. For the next kind of 15 years, gradient boosting is the winning solution. However, at the kind of 2016, the Tianxi Cai from one of the PhD scientists from University of Washington further developed these ideas, combined the GPUs and the computational structure, come out with the SG boost. Now these days they broadly used. So we talk about the product thinking and how can we as a statistician also push for the last mile. This have some stories to show our statistician can better understand the theoretical part. They also show our limitations. We didn't push for the last mile. Around this, how can we do a better job? So probably the next slide we talking about some of the potential opportunities. So one part education. Later on, we have some panel discussion on the education. One proposal kind of people will think about: can we do the open source class materials and develop these class materials, because the field is changing so fast, they will take a significant amount of time. Can we do a better job, like our community have open source class materials? We also talk about the conference. Kind of Jiashun mentioned the publications is very slow. So can we borrow some idea from computer scientist conference, like the conference journals, and also the conference format could potentially, we can also think about the change. For example, I just came back from INA. There are so many of the a lot of people don't actually go to the presentation, just like in the hallway have the conversation. But many of the presentation is so short. Can we have like similar at the computer scientist conference, like have a full day workshop, have a different stream, then we can better learn the new materials and the new field. So the evaluation systems, later on we will talk about this. I also like the comments from Jiashun talking about Hilbert 23 problems. And so these 23 problems doesn't mean only the theoretical problems. There are also many of the application areas that we can better contribute. So currently, the Peter Billman, myself, Annie Chu, and also a couple of people's we are working on the kind of annals of applied statistics, that's discussion papers, and on what's the most important, what could potentially be the bigger problems in our field, in the field of the AI machine and AI machine learning. In the end, the product thinking is also very important to helping us to push to the last mile. And we probably need to think about how with our statisticians and can better understand and kind of the skilled up on our methodologies. We just shared one paper in the AI field. They call it the beta license. In the long run, how can we develop this broadly used methodology and better leverage the hardware architectures? Because this is very important for us. So that's kind of the potential actions as our team was discussed. Thank you for the opportunity.
Thank you, Haoda. We will move next to Tracy from Harvard.
I want to thank the organizers of this event for the great efforts. Next slide. Statisticians may sometimes have the fear that our methods will completely be shadowed by AI. For my own curiosity, I did a small experiment with a student. Topic model is a statistical model. We were interested in using large language models to perform topic modeling. In the first attempt, we hoped to do fine-tuning, but this requires having manually labeled documents. In the second attempt, we provided a description of the topics estimated from a statistical model and only asked GPT-4 to assign topic weights. But this is very expensive. In comparison, a statistical method only takes a few minutes to process the whole MetStat dataset, and it's free. We also tried the free ChatGPT. Surprisingly, ChatGPT eventually called the existing topic modeling algorithms. At least in this example, AI did not easily outperform statistics. Next slide. We are very impressed by the successes of AI in some fancy tasks. However, there are also a huge number of daily tasks for which statistical methods have winning edges. Solving these problems also has a great impact because the availability of low-cost and reliable methods is important to scientific researchers and everyday users. Next slide, please. There are still strict regulations of using AI to decide which students to admit to a college
or which medicine to give to a patient, or autopiloting a plane. It seems that people use AI more as a tool to collect information rather than making decisions. The output from AI can be very rich, but eventually we still want to find the signals for decision making. Next slide, please. I view AI as a new way of collecting data and creating features. We then still need to convert the output of AI to the final decision. This process involves ideas such as dimension reduction and signal detection. I think the missing piece here is a new class of statistical models for this new type of data generated by AI. Once we have such models, we can probably similarly apply the classical statistical wisdoms. Next slide. Many examples in the literature show how theoretical insights can effectively guide methodology development. One importance of theoretical research arises from the limitations of relying only on numerical assessments of methods. While simulations can be useful, it's impossible to cover all possible settings. While a paper might choose to report certain simulation settings, the error rate is an objective measure that remains true once proven. Many of the latest advancements in AI appear to be driven by engineering efforts. The previous slide, sorry, I'm still in the the question here is how to identify AI problems at which us statisticians can make intellectual contributions. The community would greatly benefit from more examples of good AI-related papers and clearer criteria for evaluating the intellectual merit of such research. Next slide, please. These are my thoughts of what we can do. Many overlapped with the previous panelists, so I'll skip them. One thing I want to highlight is that AI-related research demands significant resources, including computing power, access to non-public training data, and extensive engineering efforts. Establishing partnerships between universities and tech companies to negotiate favorable agreements could greatly benefit us. Thank you.
Thanks a lot, Tracy. And we move on to Henry Zhou from Yale.
Thank you, Xihong. The session has been going extremely well so far. So I have only a couple of superficial comments. So AI foundation might be a good area for us. We do not have the computing power of big tech, and big tech does not have the luxury to study the foundation. The foundation of AI might be different from that of mathematics, statistics, and theoretical machine learning. In statistics, this is what we did. We have a bunch of observations and then make an inference for the next observation of a similar nature. A fascinating feature of a large language model after pre-training is in-context learning and even dialogue. So to answer the question, what they need may be just a few examples, and sometimes they do not even need any example. So this to me is not really statistics, but definitely probabilistic. So, okay, why I put an award 1939 over here. His story is inspiring. And the award single-handedly laid the foundation of theoretical statistics, while he did not really know a lot about statistics then. He was writing his 1939 paper while taking statistical courses under Hongtu, starting from fall 1938. But of course, he was a brilliant mathematician and learned game theory and from Morgenstern, and which happened to be enough for him. A similarity here is we do not know much about large language model or AI. Can we do something? Next slide. In the past decade, we witnessed significant expansions of statistical departments. A tradition and strength of statistical community is collaborating with other disciplines. And that's the main reason of our collaboration, our expansion, I think. So can we keep the momentum or even reach a higher level with the new tools AI development? What I had in mind is not exactly writing a data analytic book in a month with the help of ChatGPT, such as a recent book, a popular book, and What Makes MBA by a best-selling author. What I'm hoping is in-depth collaboration, as mentioned by some panelists, collecting new data and doing fine-tuning. And fine-tuning was made possible for us due to some tools developed and such as LoRa. That means we need to code. It's not just for students and junior faculty and for senior faculty as well. Although, some exciting recently developed tools would help us code, at least code better. And Xihong asked me to add a few action items. I don't know exactly what Xihong has in mind. And I have some bold ideas for discussion, but with a very limited scope. First, I think for statistics departments, we may hire people in large language model, or more broadly AI, and see AI as an extension of data science in order to build more collaborations with other disciplines, including humanity, law, and social sciences. Although that's not where the money is. For journals, we may add AI researchers on the editorial board and encourage our junior faculty to publish in top AI conferences, and which will be part of the evaluation process. Oh, okay. I have to stop. Thank you.
Thanks a lot, Harry. And so thanks all the panelists and for the insightful and stimulating presentation. Now let's move on to our discussant and Professor Dave Donoho from Stanford University.
Can people hear me?
Yes, Dave.
Yes.
You hear me okay. Am I allowed to share screen, or that doesn't work?
You are allowed to share. Jing, can Dave share screen?
Yes.
Okay, so let's see. So I'm not agile enough to actually record everything everybody said, first of all. So I do want to start with the following, that I guess I'm an honorary member of ICSA because I was an invited speaker at one of your conferences some years ago. And so I would like to thank ICSA for welcoming me into this community. And I'm really proud of the discussion that I've seen here. I think every discussant or panelist has provided a significant contribution, and there's plenty to think about here. So it's a privilege for me to have the chance just to be a fly on the wall and listen to these things. And also, I like the fact that you provide sort of a backbone of the future of our discipline. And maybe a lot of things that I wish people were discussing in my daily life in Sequoia Hall, I am hearing them discussed here. I also know, because I had a chance to speak to some graduate students at different universities, that graduate students are very concerned about all of these issues. Whereas maybe senior faculty are not discussing them very much. So it's a tremendous relief to me to hear that the panelists here are thinking about these issues, because I would hate to think that a huge daylight is developing in between our faculty and the graduate students. So this first of all is very good. I feel there's many things were said here about maybe it was considered threatening. I'll just throw up, if I can share screen, I'll just throw up one thing here. Do people see
Yes,
this?
We can see this.
Yeah. Okay. So possibly you've used the Google Books Ngram viewer, and you may have made a plot like this before, and you can see that data analysis, since Tukey coined the phrase in the last part of the 1960s, has been an important topic. It was, at the moment it was launched, pretty much single-handedly, it became like overnight as important as statistical analysis. Data science was just launched in this decade, and it's rapidly increasing, whereas statistical analysis seems to have been declining for almost 30 years in frequency within the language. Now, another graph that you could make is this one, that artificial intelligence had a peak much higher than statistical analysis already in the late 1980s, and then was declining since then, and has shown some rebirth in recent years, signs of life. On the other hand, machine learning started in the mid-80s and has been increasing ever since, during the whole time that statistical analysis has been dropping. Meanwhile, data analysis sort of flat, and data science is coming along and sort of equaling statistical analysis. I think that's that's part of the what's going on out there, is that there's all of this buzz, and some of it is real, but some of it is not. I mean, AI has been a term which has been heavily used for years and years, and it didn't really deliver, but now everybody's using it, right? So that if you look at the European AI regulation that just came out, the Biden AI regulation, and I'm sure other global bodies are considering this, it's top of mind. But I heard some of the panelists seem to say that there's sort of AI and then there's statistics. And I would counsel against thinking that way. Something that was helpful to me, because I once spoke at this spring joint AI conference, which is a lot of the AI luminaries of Stanford and MIT. AI is just a field that anything that works, they just appropriate it for themselves. So on some college campuses, there are complaints about cultural appropriation, like one field taking over from another, or one culture taking over from another. But this is a very clear example of cultural appropriation. They simply are going to take and rename and obfuscate whatever we produce. And it's just the way it is. That's in their DNA. But it doesn't mean that we are not in AI. From the outside world, we're all in AI. It's just some of us are grumpy about AI, and we think that there's some injustice about it, and we call ourselves statisticians. Maybe we shouldn't be so grumpy. Maybe we should start wearing AI t-shirts and figure out how to participate in this whole thing, possibly. And then there's also the thing about being grumpy about tech hegemons. Maybe we shouldn't be so grumpy about tech hegemons. In the end, they're looking for bright students. And so the best thing we can do is maybe place some of our students with them. I have a student working at OpenAI. I've had other students. One of my first, I had a student who was the first statistician hired by Google. I think we can be proud of whatever hegemon placements we get. So I agree that there are these things, they're concerning, they're shocking when they first hit you, but it could be that if we just join the team in some sense, we'll be happier. Now, how much time do I have at this point, or is that about right?
I think that's about right, Dave, and we will.
Okay, but okay, one more comment. I
Sure.
mean, there were many great things that were said here, but there's a mindset difference between the fields, and I think we need to be cognizant of that. Namely, the people who are in CS has the feeling that we don't need any new ideas. We just need scale. We need data and computing, and we need to just build larger and larger models and larger systems. Okay, and so the story of the last 5 years particularly is an amazing advance in scale. In fact, the bitter lesson is a blog post that describes that literally we don't want math. Literally, we don't want any clever ideas. We just want scale. And so whenever, many times a day, you'll see Twitter responses to things where people just say hashtag bitter lesson. And essentially that is something polarized against us, so to speak, because they're rushing to scale. Okay, now that's fine. In my opinion, what's going to happen is they will reach the limits of scale very soon because of the tremendous resources on scales of trillions of dollars. They'll very quickly reach the limits of scale because they literally don't want ideas. And then they will need ideas again. And if we show up wearing AI t-shirts and provide them some ideas, we will, feel the love. So instead of being grumpy again, we can just be like, patient people waiting until the love comes back. As long as we don't polarize against them and isolate from them, many of these challenges will transform into opportunities. Okay, I've taken too much time. Thank you.
No, thank you so much, Dave. Very thoughtful. And so just following your points about the join the force and how can given multiple panelists have discussed the current limitation of the AIs then how this provide opportunity for statistician. So how can the statistician effectively join the force and make the contribution more visible?
Are you asking me, or you
Yeah,
want?
just in general, I think maybe Dave, you can start. Yeah.
Well, I do want to point out that there are fantastic amounts of financial resources going into research in AI. And some of it's commercial and some of it's governmental, but it's out there, and any of us can tap into that. And it's foolish for us not to tap into it. So as far as the how, well, team up with people who are looking, who are like in a CS department or in a medical school who want to access any of those resources. I'm sure there's any number of doctors that are out there that ordinarily biostatisticians would work with on some clinical trial. And now the doctors are trying to develop a large language model for something. And they just need people who are good with with data engineering, adopting processing methods, like that's an obvious one. And there's many similar things.
Yeah, I can get, thank you, David. I think about the large scale might reach the bottleneck. Just for example, we know the solar actually so far can only generate about 60 seconds AI video. It's a really brilliant idea, but the bottleneck is only 60 seconds video. So how could a statistician can contribute to, let's say, using some clever way that not just stuck with only using large parameter, large GPU, TPU, these kinds of things. We can simplify. Let's say we can do good data integration, and therefore we don't need so many large models, and we can do something a little bit smaller scale. And also, let's say Altman said, eventually we're going to run into energy crisis. OpenAI use a lot of electricity, fresh water, and this is a problem for even for the Earth, for our human being. So we need to think something much broader, and we can help the OpenAI.
Thank you, Bing.
Yeah, first, I just want to resonate with what Dave said about wearing the AI t-shirt. I think it's very important that we just join the community, going to submit to SML, NERSP, and iClaire. It's one place to start. But at the daily life level, I think talk to the CS students who are in your classes, engage with them, go to the CS seminars and offer ideas. And then join their proposals. If there's a call for AI Institute, find out who is leading on campus these initiatives and just invite yourself. I think one thing I learned in the data science initiative for the last 10 years, CS culture is a little different. We kind of polite, we want to be invited. They usually just, well, everybody's at the table, invite yourself. So that's something, it's a coding difference, but if you just invite yourself and reach out to the CS chair, for example, if you don't know who to talk to, just say, well, there's this AI proposal. I'm sure some CS faculty probably organizing something, who are leading this. And this way, we just invite ourselves in. But ultimately, it's whether in 5 years, this group or larger community will have some poster child like successes saying that we are one of the leaders for these huge projects. And there will be a test that whether we can really rise to meet.
Thanks, Bing. Tianxi.
Yeah, I totally agree with the points you raised earlier. I just want to mention one thing is that I do think that our students and also moving forward for us as a discipline, we do need to change our mentality of waiting for data, and data processing somehow is not our job. Then we really are waiting and begging for data. But I understand like collecting data itself takes a huge amount of resource, but maybe we should create shared infrastructure or knowledge source, etc., to enable our students to touch the data more quickly so that we don't have to wait for data. I think we have the ability to come up with much better algorithm or equally good, and everybody has a unique contribution. But I do feel that CS or even biomedical informatics students are much better at just get their hands dirty and never think data processing is not their job.
Thank you. So we are about the time move on to the next session. It's really a lively discussion. I know there are lots of questions and in the Q&A, and so we will have the panelists answer those questions by typing the answers. And so thank you very much and for the lively discussion. And so